Welcome to a design video from the Ultralight Airplane workshop. My name is Leon. In this video, instead of part of an airplane design, we're going to talk about the design of a vertical hot wire cutter. If you are not familiar with what a hot wire cutter is, it is a mechanism for cutting polystyrene foam. And what you use to cut the polystyrene foam is a hot wire. It's got to be hot enough to melt the polystyrene. That's a hot wire cutter in general. Specifically in this video, we're going to talk about a vertical hot wire cutter. Your typical traditional hot wire cutter is usually a bow shaped. So it's going to be shaped a little bit like a long bow saw. And it's going to have a wire with the electricity hooked up to two ends of it. And running that electricity through the wire heats it up. You want to heat it up just enough that it'll cut the foam, but not so hot that if you happen to stop while you're in the middle of cutting the foam, it doesn't melt a very big circle around the wire. In order to adjust the heat of the hot wire, in other words, adjust the current going through the hot wire, you need an adjustable voltage electrical transformer. There's probably a wide range of wires that you could use for a hot wire. The most traditional one is a nichrome wire, and you can get that online just about anywhere. What I'm using is stainless steel safety wire. And so far, it's worked out pretty well. It's fairly cheap and it's pretty easy to get. The way you use a bow hot wire typically is you're going to need two templates. You're going to have a template on one side of a piece of foam. In this case, I've got a little airfoil shape here. And you're going to want another template on the other piece of foam. Then what you do is you run the hot wire into the foam and you follow along the edges of those templates. Now a piece this size you could probably do with one person, but once you get up to about 3 feet or so, it's difficult for one person to handle that bow hot wire and advance it at the rate you want on those templates. Frequently one template is going to be a different size than the other one, so if one of the templates is smaller, you're going to want to run the wire along its edge a little bit slower than the template that's bigger. You want the wire to run a little faster along that. And a 3-foot long piece of foam, you can't see both sides at the same time, which means it's going to be really difficult to get those rates right. So that's typically why you need two people running a bow hot wire for a long piece. But even when you're doing a short piece, it's still not really easy for one person to do it. What if you don't have that? What if all you want is to either make parallel faces or right angles? In that case, you might want to have a vertical hot wire cutter. And right here is a good example. I cut this using the hot wire cutter with this face down along the table, and then I cut this edge. So this is now a nice 90 degrees between this face and this face. Now if I wanted to, and I wanted to have this face be parallel to this face, I could set up this fence for whatever width I wanted to have this and just run it through, and then this face and this face would be parallel. And you can even use a template. Let's say this drawing that I put on top of this foam is actually a template made out of wood or countertop formica, something like that. I can attach that template to the foam, and as long as I had a nice flat face here and I got rid of my fence, I could actually run this wire along the edge of the template. Now that means that all of my cuts would be perpendicular to this face, but I can still get curves. That means that the shape on this side should be identical to the shape on this side. And it's much easier for one person to do this. You don't need two people for this type of operation. And as long as you're interested in having the same shape on both sides, you only need one template. You don't need two templates. So there are some advantages for having a vertical hot wire cutter. Let's do a quick overview of this vertical hot wire cutter that I made. The vast majority of this hot wire cutter was actually made out of scraps that I have around my shop. There's very little that I had to actually go out and buy, which is fortunate because so I saved a lot of money. But we've already talked about the main element of the hot wire cutter, which is the vertical hot wire. Now I've arranged this hot wire so that it is 90 degrees to this table between this pulley and the hole that I've drilled and run the hot wire through. Now this post here is something similar that you'll see on bandsaws, except in bandsaws it's usually something vertical. It's a mechanism for holding your cutting blade so that either it doesn't twist, but of course we don't have to worry about that here with the wire, or it doesn't bow in or out. And that's the main thing that this post is for, except it's got two features. It keeps it from bowing in and out, which is the major feature, because if you are pushing against a template and cutting, you're going to be pushing into the wire will come up to the template, but if you're pushing and you don't have one of these holding posts, this wire is going to come in this direction, which means it's no longer 90 degrees. And then you're no longer going to have your 90 degrees here. So what you want to do is take this post and set it so that it's just barely above where that template's going to be. And then as you're pushing in, you don't have to worry about losing your 90 degrees. Another feature that I have here is a fence. I can use this particular fence in two ways. Now this is a pretty tall fence. If I don't have a flat surface on the table, for example, this isn't very flat, and I want to have something parallel here to here, I can actually just press up against the fence and then push through. Now, if I didn't have a tall fence, if I had a short fence, I wouldn't be able to do that. But the other use for the fence is just as a spacer to cut a specific width that I want for the foam. And what's really nice about having a wire, you don't have to have this angle of your fence anything specific. All you really care about is the distance from the wire to the nearest point on your fence. So if I wanted to, I gotta have this way over cattywampus on like that, and all that really matters is this distance here. So unlike a table saw, you got a little more flexibility with your fence. Now if I'm only using my fence as a spacer, I don't need this big hunkin' piece of aluminum. I could use something like 1-inch angle, and that would work just as well. Well, of course, you have to have electricity running through your hot wire, so let's talk about that next. Now, as I said, you need some way of putting electricity through your hot wire in order to heat it up. I happen to have this old transformer from way back in the early 1990s. Now this one says it's from Calrad, but I do not recall where I bought it from. But you use this knob on top to change the output voltage from 0 up to whatever your maximum voltage is on your line. Now here in the US, we use 110, 120 volts. Now for the length of wire I've been using, around 22 volts or so is worked pretty well. Back when I was using my bow saw, which had about a 4-foot length, I have a mark here at about 17 volts is what I used to use. The stainless steel wire that I'm using is 25 thousandths thick, 0.64 millimeters. It's safety lock wire, T302-304 stainless steel. And so far, it has worked pretty well. Let's follow the electrical path. These bottom lugs are the input where you put in the 110 volt AC. The top lugs are the output, which puts out whatever voltage you set on this dial. Now this is AC output on this particular transformer. It really doesn't matter how these lines are hooked up. Now this line here is one of the very few things that I actually purchased for this project. This is a 6-foot long extension cord. I wanted lamp cord. I didn't happen to have any. I couldn't find the lamp cord that I normally have. So I quickly went out to Home Depot and bought a 6-foot extension cord. And the reason I wanted lamp cord is it's easy to split. I could have used something like a 6-foot computer electrical cable or a printer or some sort of electrical appliance electrical cable. That would have been fine. It's just a little bit more of an annoyance to split that out, particularly the split that I'm just about to show you. But I put myself a couple of electrical lugs on here to help hook this up and keep it on here. So this old lamp cord, the extension cord, runs through here, and what I've done is I've stuffed the split up in here. Let me pull it out for you real quick. So here's where the split is. So the end that's going in this hole goes over to the other end of my hot wire. The other end from the split comes over here to this back end of the hot wire. And again, I put an electrical lug here on the end of my lamp cord. I've attached it to a little bolt, and then on the end of my hot wire, I've also put an electrical lug. Now you want your hot wire to be straight, which means you're almost always going to have to put some kind of tension on it. And now there's all kinds of ways of putting tension on it. But one of the drawbacks that you have on your tensioning mechanism is that when your wire heats up, it expands. On those bow hot wire cutters, some of them just have something like an all thread with threads on it, and you tighten it up, but then when you go and apply electricity to it and it gets warm, it's going to expand and get loose. So what you're going to have to do again is tighten it up again. Now you have to be careful though when you go to turn off electricity. Before you turn it off, you have to loosen up those threads. Otherwise, when the electricity stops running through the hot wire and it cools down, it's going to get too tight and break. Another way is to use a spring. A spring works pretty good, but you're not going to have a consistent amount of tension on it all the time. The amount of tension that a spring applies depends on how far it's either stretched or depressed. I wanted to go for constant tension. So what I did is I arranged a way to put weights on the back end of my hot wire. So that's what I've got here. I've got 3 steel blocks, and they're about 5 pounds each. What I've done is I've cut a slot through these blocks that the wire can go through. And on this bottom slot, I've drilled a hole that my electrical lug can go up into. So what I do is I put the wire through here and get it up to the center. I've also made these slots just a little bit past the middle so that as the weight is hanging, it leans toward the heavy end, which is toward the slot. That helps prevent the weight from falling off. Let's put all the rest of the weights on here. So electricity runs into the bottom of the wire, and then it runs up along the back side of this arm up to this pulley. Now this pulley happens to be another part that I bought for the project. This is a sliding glass door roller bearing. But what I'm using it for is to deal with how the wire is going to expand and contract as it heats up and cools down. And this pulley helps take care of that. It'll roll just a little bit as the wire expands and contracts. The wire then runs through a hole in the back of this arm. It runs through the arm up to the front. The hot wire then goes through a hole here in the end of the arm over another pulley. It's the same one as I have in the back. And then it comes down. It goes through a little slot here in my hold arm. And then it goes down through a tiny hole, a hole just a little bit bigger than the wire, down through my table. I've taken the weights off the hot wire so I can show you the other end of the hot wire and where electricity hooks up. Now I did not put a lug on this end of the hot wire. I want to be able to pull it back through the hole that's in the top of the table. But in this case, it's just wrapped around a bolt, and then the electrical wire is on a lug, and then all those are on the bolt bolted together. And then when the tension is on the wire, this bolt is pulled up tight against the bottom of the table right where the hole is. Let me give you a real quick view of my cross holding arm. Now hopefully you can see that there's just a very thin slot that the wire fits into here. Now I've cut some angles here on the end of this piece so it's a little easier to see where I'm cutting. And by the way, I'm not getting this hot wire hot enough to burn the wood. So using wood for this is perfectly fine. Now this is 3/4 inch by 3/4 inch solid oak wood. I used some C-clamps over here to help secure it. That makes it fairly easy to move it up and down as I need to, and a little bit in and out. Now you can see there's a little shim here that I had to add in because I didn't get this arm here placed quite right. It was moved a little bit too far out, so I had to put a little shim in here to keep the end from being too far in or out. Both of these upright pieces are also 3/4 inch solid oak. This little brace piece down here, which I'm actually using as a fitting, is also solid oak, and then there's an identical one on top here. These are screwed in and not glued in so that I can easily change them if I want to. This pulley that I've got the hot wire running over is attached to some 1-inch U-channel. That's some scrap that I had in my shop, so I didn't have to buy that. And on the back side, this is some 1-inch by 2-inch tubing that I also had as scrap in the shop. I wanted to have 2 inches here to get this wire far enough out that my weights wouldn't be touching or dragging heavily back here and reducing the tension. For attaching the fence, what I did is I added a couple of rails on the side of the table. There's one here on the back side that I use a clamp on. The clamp on the backside, if I clamp it tight enough, will almost hold this without rotating it left and right, but not quite. Now, of course, clamping it causes this end to lift up, and then on this end, again, I have another rail, and I use a spring clamp to hold this end down because this does jump up if I don't put a spring clamp on here. And it does provide some friction to help keep the end of the fence from sliding side to side. Another thing I could do is actually extend this rail farther on both this side and the back side, and that would allow me to put my fence over on this side if I want to. And if I ever need to do that, I'll go ahead and put the rail on there. Now these rails are simply 3/4 inch by 3/4 inch solid oak. Now for those of you that might be interested in the details, let's go over some of the dimensions here. Now all the wood that I used in this project was scrap. Almost all of it was from an old entertainment center, and some of it was from a homemade bed that one of the neighbors threw out. In fact, the pine here was from that old bed. So the pine that I used all the way around for the thickness of the table is 3 3/8 inches high. Now all the plywood that I've used, the big parts, are all 3/4 inch thick. They are oak veneered, but they're actually pine plywood. Now the table itself, the dimensions are 35 inches long and 22 inches across. And just so that you'll know, this cutting area in here is 12 inches from the wire to this fitting right here, and 15 inches from the table up to just under this arm, but also with the holding arm up here. One of the reasons this table is so thick is I wanted it to be rigid. I knew there was a possibility that if I put some moderate force on this wire that transferred up to this arm could do some twisting and some bending, and I didn't want the table to also bend. So it's fairly thick table, probably thicker than it really needs to be, but it's pretty darn rigid. I did not glue anything on this hot wire cutter together. Everything's been screwed, and almost all these screws are about 4 inches on spacing. Let's talk about some dimensions on the arm. I've drawn almost all the dimensions out here. So from the table up to the top of this board here, 23 inches. This board is 6 inches, and in fact, this board is 6 inches also. And as you can hopefully see, this top board is 23 inches. So from the back to up to this front board, 23 inches. And this board is 16 1/4 inches long. This arm is hollow. All it has are these 3/4 inch boards on each of the 4 sides, plus there's a 3/4 inch by 3/4 inch stringer at each corner that adjacent boards are screwed to. So there's a 3/4 inch board running through here that we're screwed to here, and then right here at this edge we're also screwed to it. So there's a board here, down here, there's a board here, and of course here and here. So anywhere you see these screws on this face, there's a 3/4 by 3/4 inch board back there that hooks it to the adjacent board. I'll take the end cap off here and give you a view so you can see what those boards look like, at least from the end. So here are the stringers that are running through this arm, and you could probably also call them longerons if you wanted to. So all 4 of these actually run from this front cap all the way to the back of the arm. And as you can see, the screws are sticking out through here. The screws I had were also something I already had in the shop, so I used what I had available. I think the last dimension that I haven't mentioned yet is the width of the arm, and it is 4 1/2 inches across. Another feature of the design to help keep this arm stiff is that I put a 3/4 inch board here that runs all the way across the table underneath. And that helps keep this arm at the front from bowing down the table, or actually even bowing it up. So that adds more stiffness to keep this arm from moving. I want to do a hot wire demonstration for you, but before I do that, I want to mention that you should never ever hot wire PVC foam or polyurethane foam. Both of those will give off toxic gases if you melt them. Polystyrene is the only one that won't kill you as you're cutting it. So go ahead and cut polystyrene with the Hotwire all you want. Do not use polyurethane or PVC foam on the Hotwire. Let's do a little demonstration with this Hotwire cutter. Now right now I've got it set at 20 volts. Let's cut into it. Now when you first push in, the Hotwire is very hot and it cuts fast. But after you get about ½ inch in or so, the foam cools that Hotwire down and it'll cut slower. Now I'm going to pause for just a moment here and we'll see what happens when we pause. What should happen is the Hotwire will start heating up a little bit more because you're not cooling it down with the foam, and so it'll heat up and it'll make a little bit of a hole there where it heats up. But we'll start moving it again and let's pull it out. So here is where I stopped. So I came clear up to here, stopped, and moved on. Let me put it here together again, and you can see where that hole was where I stopped. So you really don't want to stop. You want to keep as constant a speed as you can. But one nice thing about this vertical Hotwire cutter, if you want to put a drawing on here and then Hotwire to the drawing, you can do that. You can do freehand, freeform, just cut it any old way you want to. We'll do kind of a little puzzle box shape. There you go. So you can do some pretty fun things with a vertical Hotwire cutter. I made this video as one of the benefits for my patrons that are the builder tier and designer tier. For the designer tier every month, I typically have some sort of a data file that has to do with the design of an airplane. But this month I didn't have that because I've been building all month and hadn't made any files. So this little design video for this Hotwire cutter is a substitute for that data file. I want to thank Keith and Richard for being fantastic designer tier supporters on Patreon. You guys really rock. Thank you. If you guys might be interested in some more of these side design projects, let me know down in the comments for this video. Another one that we could cover is the apparatus that I'm going to create for doing the shear test on composite samples. So it might be another fun one to make a design video on. Until next time.